Thank you for joining. In the previous lessons, we implemented implicit and explicit model binding using various attributes and POCO class objects. In this lesson, we will discuss topics such as form fields, request body, and request headers, together with attributes ApiController, FromBody, FromForm, and FromHeader. As you may recall from previous lessons, the order of implicit binding starts with the form fields and then checks the request body and so on. Let's explore these methods one by one. When we submit a web form, we primarily use two HTTP methods, get and post. The method used and how data is sent, either as query parameters or in the request body, depends on how the HTML form is configured. If the HTML form is configured with the method attributes set to get, the data from the form is typically appended as query parameters in the URL. This approach is often used for search forms, where form data is visible in the URL. Conversely, if the HTML form is configured with the method attribute set to post, the form data is sent in the request body rather than as query parameters in the URL. This method is commonly chosen when you need to transmit sensitive or large amount of data, as it remains hidden from the view in the URL. In this case of a search form, the choice between using get and post depends on several factors, including the amount of data being sent and whether it contains sensitive information that should remain hidden from the client. We have had plenty of practice with a URL encoded query string parameters in previous lessons. Now let's practice working with data sent in the request body. If we open Wikipedia page as an example and navigate to the login page, in the DevTools Elements tab, we will notice that the forms submission method is post. This indicates that sensitive information such as login and password will be sent to the backend server via the request body, ensuring that this information remains hidden from users. So when I enter my credentials in this form, the text I input will be transmitted using the HTTP or HTTPS protocol and then passed to the backend server and subsequently to the database and so on. On the other hand, if we inspect the submission HTML part of the Wikipedia search form within the HTML page elements, we will observe that it doesn't specify a submission method like post or any other methods. This is because the default form submission type is get. When we enter a few words into the Wikipedia search field, the resulting request will be in URL encoded format with key value pairs. Consequently, when we press the search button, this string is sent to the backend server, and depending on the configuration, through HTTP or HTTPS protocol. It uses the get method and is transmitted as a standard URL string with appended query parameters, making the data visible and easily readable. So the GET request can be linked to a postcard, which is visible to everyone along the way, and the message on a postcard can be read by anyone handling it. The POST HTTP request, on the other hand, is like a sealed envelope, where the content inside the envelope is not visible to casual observers, but can be exposed. When using the HTTPS protocol, the message in the envelope can be encrypted, ensuring that only the intended recipient can open and read the contents. The POST request can be sent in different formats, and it can transfer data in the request body, which can be secured with HTTPS to encrypt the data during transmission. However, the key difference between these two examples lies in the content type and how the data is structured. In the first example, JSON is used, and the data is included in the request body. This format is typically used for more structured data and is common in API requests where data is serialized as JSON objects. In the second example, form URL encoded data is used, and similarly, the data is included in the request body. This format is typically used for submitting form data, similar to how HTML forms work. Both JSON and form URL encoded data can be encrypted and secured using HTTPS, ensuring that the data is protected during transmission. The choice between JSON and form URL encoded depends on the application's requirements and the structure of the data being sent. Let's open Postman. To achieve the FromForm model binding, which is the primary option in NetCore, in Postman we have two methods to send it. The first and most commonly used option is to send the form using form URL encoded, as we have just seen in the diagram. This option is currently selected in Postman, where I have defined two key value pairs named in accordance with URL string segments vs and auth. If we place a breakpoint and send a request to the last lesson's code, which we created for testing purposes, we will receive both values into the myPoco class. This happens because it's sent as a form from Postman, and since the myPoco class has no explicit model binding, the form fields are the first option for implicit model binding within the NetCore framework. Consequently, we receive the correct reply. Behind the scenes, the data will have a format like this. This represents the URL encoded data sent using the request body via the HTTP protocol. And this is exactly how the server received this data at this very breakpoint. We saw this example on the diagram just a minute ago. I will add a few lines of code to demonstrate that the data was received exactly as key value pairs separated by an ampersand. This code will retrieve the data transmitted in the request body. If we send a request, we will receive this data back. As you can see, the data we received from the body looks exactly like query string parameters here, separated by question marks and ampersand symbols. That's why it's called URL encoded. It's structured as a series of key value pairs, similar to query parameters in a URL, but it's sent securely as part of the HTTP request. In contrast, query string parameters are sent using the HTTP protocol request line and are not secure. The second option is to send data using the form data option. It also consists of key value pairs, but the format is different. If I send a request now using form data, we will receive a reply with content type and content disposition. This method is typically used when you send a request and attach a file, such as an image or document. With form data, we can send it as a key value pair, which is the first option with this type, or the value can be a file. You can attach a file to this request, and the reply will include the key name, and the value will be the file name. Additionally, the file's content is included. This form data option is primarily used when sending a large amount of data, like a form with numerous fields resulting in a substantial amount of text, or when you need to attach a file. We will cover form data in more detail later in this course. For now, we will continue using the form URL encoded option. I will revert the code back and let's see the model binding in action. First, if I remove any explicit binding in our code, the model will be bound using the form URL encoded option only. As you can see, the reply consists only of the key value pairs we provided in the form URL encoded part. Neither URL segments nor URL query parameters were picked up by the server. So in the lower part of the diagram, that's what the data we have just sent looks like. First, there is the method type with a URL string, followed by the host, the header's content type, and the data itself in key value pairs combined using ampersands. So it's transferred in the HTTP request body. Let's revert to our explicit binding. In regard to the first two parameters, they will be bound explicitly, while the Poco class model binding will be determined by NetCore 7. When we send a request, the first two responses from the server are explicitly model bound, and the Poco class is bound implicitly. As a result, we obtain these two values from form URL encoded data. Since the form is the first option checked when NetCore attempts to bind the model, the same response will occur if we bind the model explicitly using the FromForm attribute. When we send a request, the outcome will obviously remain unchanged. Now let's remove the explicit binding. We will send a request using the body and JSON, which is the upper part of the diagram on your screen. This request can be sent using various formats such as JSON, XML, CSV, and so on. This option is used to process more complex data in ASP.NET Core 7. A media type formatter is used to read the value from the request body. If we need to use various formats, like XML as an example, then we would need to use an XML serializer formatter method, as not all browsers support XML. JSON is the default response format for ASP.NET Core because it is a lightweight and efficient data format that is widely supported by modern browsers and devices. In Postman, I choose body, row and JSON, and then send a request. As you can see, this body part is completely skipped in the response. Even though the request body comes before the route data and query string parameters in implicit model binding, as you can see, the response contains data only from the URL. To retrieve this data from the body implicitly, as I mentioned in the previous lessons, we need to uncomment the ApiController attribute. The ApiController attribute, figuratively speaking, acts as a trigger between form and body implicit model binding because it informs ASP.NET Core that the controller is of ApiController type. API controllers differ from regular controllers in that they are designed to handle HTTP requests from external clients. So the ApiController attribute tells ASP.NET Core that when a request is made, the controller is of the API type. Consequently, ASP.NET Core will first check to see if the request has a body. If it does, ASP.NET Core will attempt to bind the request body to the parameters of the action method being invoked. If the request does not have a body, then ASP.NET Core will try to bind the route data and query string parameters to the parameters of the action method. This is what happened with this request. So with ApiController uncommented, .NET Core enables the request body in JSON format. Consequently, when we send a request, we see the response of the implicit binding from the body. However, if we switch to form URL encoded, as you may recall, we will encounter a media type error. This is because the media formatter is unable to process URL encoded data in the body. It means that .NET Core doesn't include a media formatter for URL encoded data when the ApiController attribute is missing. To avoid this error with the ApiController attribute enabled, we need to explicitly bind the form fields using the FromForm attribute, like this. So with the ApiController attribute included, we are informing .NET Core 7 that the controller is of API type and we want to explicitly model bind the POCO class with the form fields. If we send a request, the error is resolved. Alternatively, we can remove the explicit model binding. And then the FromBody attribute will be triggered implicitly. Remember, it's always better to bind the model explicitly. This will help debug your code and reduce headaches for your development team members. So I will explicitly bind the POCO object with FromBody. In the event that the controller type is different from the ApiController type, and let's comment out the ApiController attribute, the explicit binding will also work in this case without causing an error. Now let's discuss FromHeader. In the context of HTTP requests, headers are an integral part of the communication between a client and a server. They convey important metadata and information about the request. It's extremely rare for a valid HTTP request to have absolutely no headers. In a typical HTTP request, you will always have headers like host and user agent at the very least. This means we can access these header keys to obtain their values. You can refer to the diagrams we have seen earlier. In the previous lessons, I also explained how headers work, how they are transmitted, and how we can access them using HTTP context request headers. However, there is a shortcut available, and this shortcut is an attribute named FromHeader. In Postman, if we open the headers section, we will see the headers that will be included in the request. It's not a full list, but for this lesson it will suffice. The process is quite straightforward. For example, if we take a string type parameter, we can ask .NET Core to provide us with the content type header like this. So we bind the model explicitly with the FromHeader attribute. In the parentheses we specify the key of the header, and we need this parameter as a string type. When we send a request, we get the correct reply. It's exactly the value that is included in the Postman header. Using the same approach, we can access any header we need. It's quite simple. In the next lesson, we will continue with our project planets and we will implement a repository pattern. Thanks for watching. If you have any questions or need further assistance, feel free to comment below. Don't forget to hit that like button and subscribe to our channel for more great coding content. Stay updated with the latest videos by ringing the notification bell. Happy coding!